Hello, and today's learning target is I can use the distance formula to find the distance between two ordered pairs. So the distance formula can help us find the distance between two pairs that are on the coordinate plane, and especially here we want to figure out the diagonal between the distance of two ordered pairs. So let's say that, I'm going to zoom in here, let's say we had two ordered pairs that were plotted. So let's say we had one plotted about right here, and then another point plotted about right there. So we want to figure out the distance between those 2 points, so I could draw a line between the two, like this, and the distance formula will help us find this. But really what's happening here is if we make a right triangle, we could calculate how to find this. So let's call that blue point here x1, comma, y1. So we know we have an x coordinate and a y coordinate, right, for that ordered pair. And then for this red one, we'll call this x2, comma, y2. So it's the second coordinate that we see. So to figure out the distance of the horizontal distance, we could take, x2 minus x1 and figure out that distance here horizontally because that's the x-axis. Vertically, we could figure out this distance by saying y2 minus y1 because, again, the y-axis is vertical. So if we were to set up the distance formula, or if we were to set up this problem here, not using the distance formula quite yet, but to figure out the diagonal distance, d, we have the Pythagorean theorem here, which says, a squared plus b squared equals c squared. So if we were to use that in this setup, we could say d squared, which would really be like the hypotenuse, the diagonal, it's the longest side, equals x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. But when we use formulas, we don't really like to see all these squareds, so we can try to get rid of one. And so if we take the square root of both sides, we end up getting, so if I take the square root there, I have to take the square root of the other side, we end up getting d equals the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And so that, I'm going to fix that y2. And that is the distance formula, and that is what you should, I'm going to highlight this, this is what you should have memorized because we will use this quite frequently. And again, it's known as the distance formula. So let's take a look at the first example. Use the distance formula to find the distance between the following points, 5, 3 and 1, negative 2. So I have a graph here to help you visualize what is also going on. So let's go ahead and plot these points so we can kind of have a good idea for what we think the answer might be. Then we'll solve by using the distance formula for what the answer is. So 5, 3 will be right about there. I'll fix that, put one dot, there we go. And then 1, negative 2 will be right about there. And again, we have to plot on the y-axis or the x-axis first, y-axis second. So side by side and then up and down. So if I connect these points here, the distance I want to figure out is the between the red and the blue. Right there, and then I could, if I wanted to visually fill in that triangle there. But I want to figure out the distance between that. So, if you try to count, you could kind of guesstimate about what it'll be, but again, it won't be exact because we're trying to figure out the diagonal. So let's use the formula, and I'm going to label right away my points as x1, y1, and x2, y2. So I know exactly what goes where in my formula. So let's remind ourselves of what the distance formula is. The distance formula, which was above, is d equals the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. So let's go ahead and plug in our values that we have. So d equals the square root of x2 is 1 minus x1, which is 5, the quantity squared, plus y2, which is negative 2, minus 3, the quantity squared. And let's go ahead and let's solve here. Let me change colors so we can see this a little bit better. So d equals 1 minus 5 is negative 4. So I'm going to put that in parentheses and then square it. Plus negative 2 minus 3 is negative 5, and then we're going to square that. So distance equals the square root of negative 4 squared is positive 16. Negative 5 squared is 25. So here now we have the distance equals 16 plus 25, all under the square root, and 16 plus 25 is 41. And we know from our last couple lessons on approximating square roots that the square root of 41 should be between 6 and 7, right? Because 6 squared is 36 and 7 squared is 49. So 41 is right between those two. So we know it's going to be about 6 point something, but if we find that by typing in our calculator, square root of 41, and make sure you know how to do that, we get about 6.403. So if I were to round that, that becomes 6.4, the 0 keeps the 4 as it is, so it's about, distance is approximately 6.4. 6.4 units, and so that would be our answer here. But if we go back to our graph, and we just figured out here the distance D, the diagonal, we could count our blocks. So if we look here, if we count below, we get 4 here, and if we count vertically, we get 5 blocks above. So again, when we use this formula, that 4 correlates with this negative 4, and that 5 correlates with this negative 5. So really, it's like we're using the Pythagorean theorem, just in a little bit more complicated formula, but it's really not all that complicated when you go through and practice it and do a couple examples. It really isn't too much work. So we get about 6.4 here units for the distance, and let's move on to another example. So let's take a look at this next example. So I have 4, 2, and negative 3, negative 1. So I'm going to zoom in. We can even use the graph here for a visual. So I'm going to go ahead and label the points so I can see those. And so 4, 2 would be about right there. And then negative 3, negative 1 would be about right there. So the distance that we want to find is this right here. Let's make that a little straighter, but right there. Okay, so then before I get started, I'm going to go ahead and label my ordered pairs so I know what is what. So I have x1, y1, and then I have x2, y2. So then I'm going to use the distance formula. So again, D equals the square root. I'm sorry I can't write clearly. There we go. Of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And let's fill in what we have. So distance equals the square root of x2, which is negative 3 minus 4 squared, plus y2, which is negative 1 minus 2 squared. And then I get negative 3 minus 4 is negative 7 squared, plus negative 1 minus 2 is negative 3 squared. And then negative 7 squared is 49. Negative 3 squared is 9. So the distance equals approximately 58, and we can approximate that. A square root of 58, and so that would be between 7 and 8, right? Because 7 squared is 49, and 8 squared is 64. So if we go ahead and plug that in our calculator, the square root of 58 is about 7.615. So if we round to 2 places, that 5 would make the 1 round up. So this would be approximately, so distance equals, or is approximately, and that's where the squiggles come in there, they mean approximate, 7.62 units. So that would be our answer here for this example. So again, we found that distance right there on our visual graph. Let's take a look at the next example. Let's look at 2 more examples, and now we're not going to use a grid or a coordinate plane, we're just going to use the formula. So the first thing I'll do is I'll label x1, y1, x2, y2. I'm going to plug them into the formula. So again, we can write our formula down so we can practice memorizing it. So then if I plug these in, I get distance equals the square root of negative 5 minus negative 7. So when we see 2 negatives in a row, chop, chop turns to a plus. Plus y2 is negative 8 minus negative 2. Again, chop, chop turns to a plus. So distance equals -5 plus 7 would be 2, so 2 squared, plus -8 plus 2 is -6 squared. So distance equals 4 plus 36, so the distance equals the square root of 40. And we know this will be between 6 and 7, so if I take the square root of 40, 6.324, so we can round that to just 6.32. And again, on the first example, I know we only round to one place value, the tenths, but that's because the hundredth digit would have been a 0. So that's why we didn't need to write it down there. But we can practice rounding to the nearest hundredth or 2 decimal places for our answer. So we get about 6.32 units. Okay, and let's look at this last example here. -4, 9, and I'll just draw a little line in here so that we don't get confused with the last example. So I'll go ahead and label x1, y1 for -4, 9, and then x2, y2 for -9, 10. So here we go. I'll change colors. So distance equals, again, we know the formula. So let's go ahead and plug in our values. So let's see if we have it memorized. So x2 minus x1 would be -9 minus -4 squared. Chop, chop turns to a plus y2, which is 10, minus y1, which is 9 squared. And now I'll go ahead and do a little bit of math now. So -9 plus 4 is -5 squared, plus 10 minus 9 is 1 squared. So now, continuing, -5 squared is 25 plus 1. So the distance equals the square root of 26. We know this will be between 5 and 6. It's a little over, actually, 5 probably. So if we figure that out in our calculator, we get 5.099. So that 9 will make the 0 round up, and then we can leave it at that because then that will be our answer. So distance equals approximately 5.1 units. And we don't have to write the 0.10. We can just write 5.1. Thanks for listening. Have a great day. Bye-bye.